kita sambung for the part 2 for today's lecture. Today's lecture, the title analysis of variance. Okay, just now we stop at slide 60. Repeated measure Anova. Okay. Okay, just now I already explained why do we do repeated measure for this ANOVA. For example, is crucial study of area given the realities of global warming. Okay, next slide. Okay, this is the carbon dioxide dataset included in the base installation contain the result of study of cold tolerant in northern and southern plants of the grass species. Okay, by Podlin et al. 1990. Okay, the photosynthetic rate of chill plant were compared with the photosynthetic rate of non-chill plant at several ambient carbon dioxide concentration. Half of the plant from the Quebec and half of the plant from the Mississippi. There is two different location of plant, and we have to know the rate of chill plant and non-chill plant. Okay, for this, okay, in this example, we will focus on chill plant. The dependent variable is carbon dioxide uptake in milliliter per saya unit-unit ni. And the independent variable are type, which is type Quebec versus Mississippi, and ambient carbon dioxide concentration. This is the okay, with 7 level ranging from 95 to 1000. Another 1 unit more. Okay, this is the ranging for the 7 level of carbon dioxide concentration. Okay, type is between group factor and carbon dioxide concentration. This is the carbon dioxide concentration is a within group factor. Okay, type is between group factor and within group factor, which is it is a mixed model, right? Okay, the analysis is present. Okay, so we do the R for this case. Okay, which is it involve repeated measure ANOVA. Okay. Okey tak ni? Ada tak? Ada tak orang ni? Saya. Okey. Saja je nak dengar suara. Okay, so repeated measure. This is for slide. Okay, Amin kita dah pakai dataset lain, which is with the treatment for chill. Then this is for carbon dioxide. Okay. We name it as W1B1. Okay, for this, sekejap ya. Okay, this is the, we run this is the subset of carbon dioxide treatment as a chill. Okay, feed. Okay, yang ni pun juga dataset ni dia tak perlu read mana-mana. Tapi macam tadi saya cakap kalau we want to read from our data, we can use the previous punya notes, which is we have to read the data, right? Okay, then we run for this. Ni dataset ni dah ada ni. Okay, if we want to use our data, sebenarnya we read, kita kena tahu yang kita punya directory tu dekat dalam tu, which is our session ni, dia ada set working directory ni, make sure that the data is there so that they can read. Okay, if there is not there, you have to put a code. Where is the location of the data? Okay. Then this is Anova, analysis of variance. We want to know this is the dependent uptake of carbon dioxide. Okay, this is the carbon dioxide concentration relation with the type plus dengan area plant divide by apa carbon dioxide punya apa tadi CONC tu
Concentration kot.
concentration betul terima kasih okay and this is the ANOVA tu okay look back at the table apa maksudnya area plant concentration yang dekat ni kita dekat page 61 yang mula tadi tu. Maksudnya yang ada error tu yang kita nak buat formula tu. Ni this is yang error subject apa ni this is one way within group ANOVA. This is the formula. But just now we are doing by using the two which is B times W, right? Repeated measure. This is what we use. Yang last kali ni tadi repeated measure ANOVA using one group. Okay, back to the slide. 61. Okay, so this is what we want to run in R. Okay. And this is the summary of fit just now. Okay, apa yang dia beritahu kat kita? Error, plant. Okay, that's it. Dan kita nampak it is significant type. And this is concentration dia tu. And it is also significant. And concentration of relation with type 0.001. And within, okay, so what does this table mean? This result summary result mean. Okay. The ANOVA table indicate that the type and concentration main effect of the type X relation with concentration interaction are all significant. This the value give the result for the type, the concentration is all the significant at the 0.01 level. Okay, the interaction is plotted. Okay, when we want to plot interaction plot ni. So we try to plot. This is the summary. Then this is the CO2 table. CO2. This is the CO2 table. What the value for the CO2 table? This is plant type, and this is the plant type is cubic, treatment is non-chill, and this is concentration, and this is the uptake. Okay. Then this is the parameter class 2 and the value of C10 tu nanti kita tengok kita nak plot apa ni. Okay, because we want to use the column C red blue. Okay, main interaction plot for plant type and concentration. Plant type and concentration. Okay. Okay, this is the value for interaction plot for plant type and concentration. Okay, we look at this table. Okay, this is the type and this is mean of uptake and this is concentration. Okay, from this, we can see that this is the type for 5 plus, and this is the concentration. That means which
Yang merah tu rasanya cubic.
oh, blue. Blue dengan apa tadi? Blue dengan red dengan blue. Macam mana?
Yang merah Quebec, yang biru Mississippi.
Okay. Merah Quebec and biru is Mississippi. Because of the merah tu dia punya it's begin with 95 is 16, right? Oh, sekejap. Sekejap
Okey,
Quebec.
doktor.
Yeah. Okay, column red and blue, type B. Okay. And for the Mississippi 95 and it is 10. Betul. Two is for the Mississippi. Okay, then for the box plot, the visualize from the box plot pula. Okay, this is Chill, Quebec, and Mississippi line. Okay. This is for the Mississippi 95 and this is for the Quebec 95. And okay, from these two graphs, saya dia besarkan. Okay. From two graphs, you can see that there are greater carbon dioxide uptake in the plant from Quebec compared to the Mississippi. Okay, the difference is more pronounced at higher ambient of carbon dioxide concentration. Okay. The data set that we worked just now is typically wide format where column are row are observation and there are single row of each subject. Okay. Okay. This is how we visualize using the repeated measure of Anova just now. Okay, this is the look back at our slide. This is the interaction that we get just now. And the Anova indicates, this is from the table, all the interaction are all significant. The interaction plot that we plot just now by using first graph that we plot and the box plot for the second plot. And okay, from either graph you can see that there are greater carbon dioxide uptake for the Quebec compared to the Mississippi, then the difference is more pronounced at higher ambience. Then for the multivariate analysis of variance, okay. If there more than one dependent, okay, if we have more than one dependent outcome, you can test them simultaneously using a multivariate. Okay, the following example is based on the US serial data set in mass package. Okay, the data set come from Venable and Ripley 1999. This example, we are interested in whether the calories, fat, and sugar content of US cereal. Okay, kat sini US cereal ni dia dah by store shelf tau. Okay. By store shelf, where one is the bottom shelf and two is in the middle shelf and the three is the top shelf. Okay. The different location of the shelf. Okay, so calories, fat and sugar are the dependent variable. We have dependent variable here, so that we are using the multivariate analysis. So this is the dependent. Previously yang sebelum ni kita buat our dependent kan macam satu je, betul tak? Which is one of the example just now is the length of the toast kan macam tu kan. Okay, this is the calories kita yang pertama. Fat and sugar are dependent. Okay, and the chef is the independent. Okay, maksudnya yang dalam equation itu islah 1, 2 and 3. Okay, then we do the analysis. Okay, while we doing the analysis, we use C-bind function to form a matrix of 3 dependents. Sebab kita dah ada 3 dependents, so we have to build a matrix. Then we use the aggregate function, okay, to know the summary shelf mean. Nak tahu mean, okay. Then we do it. Lah, sekarang kita buat. Then this is the, okay, library mask yang kita punya data just now is in the library mask ni. Okay. And we attach with the US serial. Then, okay, this is C-bind because of we are using the 3 dependent calories, fat and sugar. Okay. Then, okay, kalau kita nak tengok kita punya data US serial ni, nampak? This is the data. Which is we have calories here, fat and okay. This is the data. Then this is the head of our data. Head. Kita nak tengok 6 yang atas kan. The first 6. Nampak tak? Sebenarnya just now dia tak habis dekat sini je because we are constraint. Our constraint is for the window kita display. And if you see the 6 for the first 6 data, nampak tak? The first 6 ni sebenarnya dia punya our row tu sampai vitamin. Kat atas kita nampak. Okay, after sugar we have shelf, potassium, then vitamin. Then remember just now the location of the shelf represent as a 3, 1 and 2. Okay, then we want to know the aggregate Y. Y just now ialah yang ni. Kita punya 3, our 3 dependent just now. And we want to know in term of mean. Okay, this is the mean for calories, fat and sugar for the group 1, 2 and 3. Okay. And this is the covariant. Kan? Okay. Calories je berapa, sugar and fat. Then okay. Then we we find the Anova. Okay, multivariate. Okay, why? Okay, then this is the our variable now. It is the shelf tu. Yang mana? Sebabnya shelf tu is the independent just now kan? Variable 1, 2, 3 tu. So our formula will be y, and this is our shelf. Okay. Feed it by using Anova. Then the summary for the fit, we want to know the significant. Okay, so it is provide multivariate. The significant evidence indicates the 3 group differ on the set of nutritional measure. Nampak tak? Dia memang berbeza lah. Sebab because of the we refer to the p-value here. And the summary for analysis of variance dia. Okay. It is okay. Because the multivariate test is significant, you can use the summary .aov ni function to obtain the univariate one-way Anova. Okay, if you want to know the univariate one-way Anova dia setiap satu tu berapa, you can see by using summary analysis of variance. Just now we are using Manova kan, and the summary give for the Manova multivariate. But if you want to look at the univariate satu per satu tu, and we can look at the one by one significant value which is 0.01. Okay. Here you see that the three groups differ on each nutritional measure considered separately. So we can conclude that it is significantly different. Finally, you can use the mean comparison procedure such as Turkey HSD just now yang kita guna tadi tu. Turkey HSD tu to determine which self differ from each other for each of three dependent variable. Omit here to see. Okay, so kita boleh, if you want to know the significant from shelf 1 to shelf 2, kita boleh buat. Kamu boleh buat lah. You can write it back by using ni AOV, then Y kita nak tahu dia punya interaction, right? So kita boleh pilih lah shelf tadi tu kan. This is the shelf. Shelf tu kita kena ambil dia punya value is 1 times 2. Contohnya interaction between shelf 1 to shelf 2 boleh cari AOV dia. Guna yang tadi AOV yang analysis of variance. How can we measure the different the interaction between one shelf to another shelf? Okay. Then next is we want to assessing test assumption. Okay, how can we assess the test assumption? Okay, for multivariate analysis of variance. Okay, back our okay. This is what I'm explained just now, which is we are using summary.aov for the to identify the single punya apa factor, apa dependent punya tu. Okay. This is the result just now. And here we want to assess test assumption. Okay, the two assumptions underlying a one-way maneuver are multivariate normality and homogeneity of variant covariant matrices. Banyaknya terms kat sini kan, normality, homogeneity of variance covariant matrix. Okay, and this is what we want to know, the two assumptions underlying one-way maneuver, which is first is multivariate normality, assumption yang kita boleh buat, and the second one is homogeneity. Okay, the first assumption state that the vector of dependent variable jointly follows a multivariate normal distribution. Okay, we can use UQQ plot to assess this assumption. Okay, this is the theory. If you have P times 1 multivariate normal random vector with mean and covariant matrix, then the square Mahalanobis distance between x and mu is chi-square distributed with the P degree of freedom. Okay, the QQ plot, which is the quantile of the chi-square distribution for the sample against the Mahalanobis square value. Okay, to the degree that the point fall along a line with slope 1 and intercept 0, there's evident the data is multivariate normal. Macam mana tu? Okay, sekarang kejap lagi kita tengok dekat kita punya coding ya. How can we measure whether the data is multivariate normal or not? Okay. Then This is if the data multivariate normal distribution, then the point will fall on the line. Okay, we want to know whether our data it is multivariate normal or not. Then we look at our point, whether it is fall on line or not. Then we identify function allows to you to interactively identify point in the graph. Here the data set appear to violate multivariate normality primarily due to the observation of Wheaties, honey, gold and Wheaties. Okay. Then we do it. So, kita tengok nampak tak kat sini? Dia punya data tu dia lies on the line. Okay. So macam mana kita nak access benda ni? Okay. So look at our R. Kita tengok Okay. So this is the center. Okay. Okay, so we run it. And row and piece and column. This is the covariance of Y, and this is just now the Mahalanobis distance by using Y center and covariance value yang kat atas ni. Okay. Then we what QQ plot. This is the QQ plot. Okay. Here. Okay. Then the point we fall on the line just now. The identity function allow you to interactively identify point in a graph. Okay. Identity yang bawah tu. Dia kata kita boleh interactively point the graph. Okay. Okay, we can see that this is one apa on the line just now. Okay, one point will fall on the line. So this is the follow a multivariate normal distribution. Then the homogeneity of various covariant matrix assumption require the covariant matrix for each group are equal. The assumption is usually evaluated with a box M test. R doesn't include a function box M, but an internet search will provide the appropriate code. Unfortunately, the test is sensitive to violation of normality, leading to rejection in the most typical cases. This means that we don't yet have a good working method for evaluating this important assumption. Okay, so now from now on kita belum dapat lagi good working method untuk cari yang assumption ni punya important assumption. Okay, so finally you can test for multivariate outlier by using kita nak tahu outlier dekat sini, kita nak assess for the outlier. Cuba kita cari outlier dekat plot yang tadi tu kan. Okay. So, kita tengok. Let's see. Okay, just now is AQ plot. Okay, so we run this. No package. Okay, we put this install package. Okay, we run it. Then for the library, we load the package. So this is the how to okay. So this is the outlier. And the projection, the first, second, robust principal component proportion of total variation explained is where explain variance 0.97 and the outlier. Object outlier not found. Okay. So there is no outlier. Okay, this is what we plot. Robust distance outlier on 97.5 quantile and outlier based on the adjusted quantile. And this is the order square robust distance versus the cumulative probability. And this is our adjusted quantile. And this is the result from the adjusted quantile. Okay. This is AQ plot. Nama dekat R ni, we are doing the AQ plot. Okay, okay tak ni? And kalau macam soalan-soalan macam ni nanti kan dia kalau dia kita tengok data kita. Kalau data tu type of Anova, you have to do it by using the code yang ada dekat sini, dekat kita punya kelas ni. Kita tengok dulu type kita. And we want to know what is our first thing is the important is we want to know our formula, right? Kita nak cari apa? What is the factor? Okay. Then we want to know what is the significant difference tu macam mana. And we continue with our, this is the outlier package just now and robust Anova. If the assumption of multivariate normality and homogeneity of variance covariance matrix are unavailable, or if you are concerned about multivariate outlier, you may want to consider using a robust or non-parametric version. Non-parametric version of Anova test instead. Okay, robust version of Anova, we dot test ni dia punya function, and the package is from the RR ni, and the function for the equivalent of non-parametric Anova is Adonis. Okay, and this is, let us try in lab. Okay. Ni RR ni. Okay, so we have to install the package for the RR. Okay, we have the weak test self method. Okay, So dekat situ robust one way Anova data X weak test. Sekejap ya. Sebab dia macam tengah run. Okay, so here ini dah daripada weak test tu. How can we find from the value here? And we know that our p value is 0.002, which is it is significantly different. Then this is the shaft from the calories, fat, and sugar. You can see, from the result, you can see that using a robust test that insensitive to both outliers and violation of Anova assumptions still indicate that cereal is on the top, middle, and bottom store differ in their nutritional profile. Okay, we know that there is the difference between chef number 1, chef number 2, number 3 in terms of calories, fat, and sugar, because we see that our p value here is less than 0.052. Okay, so this is the result by using the weak dot test tool. And okay, okay, this is the test that we do. Okay, ayat tadi lah, which is on the cereal on the top, middle, and bottom store shelf differ in nutritional profile. Okay, Anova as a recreation. How can we use Anova sebagai recreation? In section 9.2, we noted that Anova and recreation are both special case of the same linear model. Okay. Just now kan yang mula-mula kita belajar tadi yang ada tengok ada LM dengan AOV tu kalau guna function tu. Okay, linear model, and for the Anova tu lebih spesifik lah kalau kita guna AOV. Okay, however, in order to understand the output, you need to understand how R deal with categorical variable when fitting model. Okay, consider the one-way Anova problem here, which compare the impact of 5 cholesterol reducing drug regimen. Okay, how can we see from this problem? And we will do the code to get this result. Okay, now we will use the multi comparison by using the cholesterol dengan apa tadi yang TRT tu? Apa yang tadi? Okay, drug regimen. Okay. This is the level. Okay, 1 time, 2 time, 4, drug D and drug E yang tadi yang kita buat tu kan. Okay, so we want to know the analysis of variant. Kita nak tengok dependent variable dia ialah respond. And this is the factor. Factor dia ialah regimen drug tu, and data ialah cholesterol. Okay. Then for the summary, we notice that okay, there's a difference between significant difference between drug regimen. Okay, for the analysis of variant for this. Okay, what can we conclude from here? Okay, yang ni ialah bila kita guna AOV kan. So we want to know the difference. Kalau kita guna, okay, this is the value and the cholesterol here, the data cholesterol kita ialah yang ni. Dia ada banyak drug. Lepas tu this is the response. And when we are using the linear model, kan, the different dia. Okay, then we can see the summary dia macam mana. When we are using the linear model, yang ni ialah apa? Okay, so we can see that, okay, 3, 2 and 1 is, so it is drug regimens versus 2 times, drug regimen 4 times, drug regimen dengan drug D, drug regimen dengan E. So kita nampak semua tu ada, they have a significance, the difference dia. Okay, so the P value dia memang rendah lah daripada 0.05. Okay. Then kat sini kita nak tengok apa? Because linear model require numeric predictor, when the LM function encounter a factor, it replaces the factor with a set of numeric variable representing contrast among the level. If the factor has k level, k minus 1 contrast variable will be created. Okay, so then kita tahu bahawa by using the linear model, kalau kita guna analysis of variance, kita akan dapat satu je kat sini. Which is the, apa tadi tu? Drug regimen dia tu kan. Tapi kalau kita nak tengok dia more specific, we can use the linear model because here we see the contrast using the apa? Variable. Dia akan created, okay, by using the regimen with 2 time, regimen drug for 4 time. Okay, then R provide 5 built-in method for creating this contrast variable. Okay, kat sini you can see that this is the intercept and all the value is less than 0.05. Then we can conclude that there is significant difference between each parameter kat dalam tu. Okay, then kat situ, this is by using LM just now. And linear model. The factor has k level, which is k minus 1 contrast variable will be created. Okay. Then here is R provide 5 built-in method for creating this contrast variable. Okay, first is contrast variable kita is Helmut. Yang pertama dot Helmut contrast the second level with the first, the third level with the average. Then for the poly contrast using the analysis linear, quadratic, cubic and so on. And the sum is the sum to 0. Division contrast, and this is the treatment. Okay, each level baseline level. First level by default, also called the dummy coding. And contrast for .SAS similar to contrast treatment. Okay. This produce coefficient similar to contrast. Okay. With the treatment contrast, the first levels of the factor become the reference group and each subsequent level is compared with it. Ini macam mana dia buat LM tu tau. Maksudnya LM yang level-level K ni dia nak apa? Dia nak decide. Okay. Maksudnya, okay, kalau treatment contrast, the first level tu, the factor become the reference group and each subsequent level is compared with it. Okay, you can see the coding scheme via contrast function in the listing. Okay. Okay, kita tengok yang listing 9.11 tu. 9.11 kadang-kadang dalam notes dekat dalam listing 9.11. Represent the contrast between. Okay, bila kita tengok yang 9.11 ni kan yang kat sini. Kat sini. Okay. We can see that 9.11 ni the variable TRT 2 times represent a contrast between the level 1 time and 2 time. Okay, 1 time and 2 time. This is the intercept. Similarly, TRT 4 time is contrast between 1 time and 4 time. Okay, maksudnya this is the level ni dia ambil from the 1 times level, dia cari contra between 1 time and 2 time. This is the contrast between 1 time and 4 time. And this is the contrast between 1 time and drag D and so on sampai drag E tu. Okay, you can change default contrast in linear model by specifying contrast opinion. Okay, kita boleh letak juga, kita nak letak apa dekat kalau kita nak custom linear model tu, kita boleh letak lah kita punya contrast opinion. Okay. Kita dah last slide dah ni. Okay ke tu? Okay, for summary, in this chapter, we received the analysis of basic experimental and quasi-experimental design using Anova, Ankova, and Manova methodology. Okay, we received the basic terminology used. Look at the example of between and within group, including the one-way Manova, one-way Ankova. Tapi kan, when you look at all the design tu ialah based on our data. And we have to determine what is the factor, and after that we have to determine, after we know the factor, we have to determine is it within or is it between the group, and is it one way or two ways based on the factor, kan? When there is two factor, it is two factor ANOVA, and if there is covariant involved, so kita kena buat Ankova. Macam tu lah. Kita kena tahu our design macam tu. But by using R, just now we notice that semua tu AOV tu lah. Analysis of variance tu yang dia punya function tu. Dia dah bantu kita lah kat situ how to decide look at what is the significant level between each factor tu. Okay, in addition, the basic analysis, we receive method of assessing model assumption and applying multiple comparison procedure following significant tests. Okay, finally, we explore a wide variety of method for displaying the result visually. If you are interested in learning more about this experimental result using R, boleh tengok dekat dalam R, Crane View. Kalau dekat R, kalau kita tengok kat R, dekat R kan, bila kita tengok, this is the package. Okay, kalau kita search kat sini R, kalau R Crane kan, kalau kita belum know the document for that particular package, kita boleh tengok dekat R Crane ni. Okay, kalau kat sini kan, for example, kalau kita nak tengok car, what is basic about axis? Okay, this is the basic power axis yang dalam car yang tadi kan kita CAR tu kan kat situ. Okay, so ini semua dia punya apa documentation lah ada kat situ. Tapi kita nak tahu yang ni ialah statistical tool ni membantu kita to measure our finding. So that we have to know first what is our data. From our data, what factor that we want to analyze, and from that factor, how many factor is there is multi-dependent ke? Kalau multi-independent is okay sebab kita nak buat formula kan. So nampak tak? Every time you do the AOV macam ni, Manova pun you have to do a formula. Lepas tu kalau macam for example, this is the formula for uptake. So we want to know the relation, then this is the error dia. Okay, then kalau tu mesti kita nak tahu macam ni weight. We want to know the weight punya impact from the factor gestation time, dose. Ada dua faktor kat situ, gestation time and dose. Okay, the significant, how significant this factor to the weight punya result nanti. So dia punya tu mesti kita tahu bahawa analysis of variance ni mula-mula kita nak kena tahu what is the factor that we want to study, and after we know the factor, what will be the dependent di sebelah dia, and kalau ada 2, 3, adakah ada interaction tu, yang tu kamu kena build the formula lah. Then from the formula tu kita kena tahulah how to susun. First is the macam order tadi tu kan. Okay, look back at our notes. Okay, yang bawah-bawah ni semua how to apply that fundamental punya apa information, but the notes yang asal-asal tu sampai sini je. Which is we design. Okay, kita nak tahu how many way, 1 way ke 2 way ke, and we want to know how many dependent variable. Kalau dia punya dependent variable tu macam tadi dia ada banyak, contohnya dia ada sugar, dia ada kolesterol, apa semua tu dependent banyak, so kita kena guna multivariate analysis macam tu. So then we use je, teruslah guna AOV ni macam tu. So analysis of variance ni membantu kita to conclude something, whether it has the significant by determining the significant level to conclude something. Macam itulah. Okay. Any question? Okay tadi. Nanti kalau lab punya assignment, kamu akan group by 3 lah. Ya. Yeah. Kita ada lab punya assignment tau.
Lab
Lab
dia boleh grouping. Kalau project?
Dia akan ada test nanti. Dia ada berapa? Dia ada
Silap saya ada final dengan midterm. Tapi lab assessment tu saya tak sure sama ada task ke apa.
assessment tu dia macam assignment lah. Yang tu kat
Assignment.
situ dia kena buat by group.
Okay.
Saya rasa nanti kan akan ada lab dengan project.
Alright.
Dia
Okay.
ada 2 tapi by group lah. But belum buat lagi. I plan to do the cleaning data punya tu lah, satu soalan. Maksudnya macam mana? Yang tu kena tengok balik nota yang last week yang pasal R tu. How to combine multiple structure, how to identify inside the column tu, data dia numeric ke atau bercampur-campur ke, atau macam mana we want to standardize that particular column tu semua numeric data. We have to set. Kan kita nak, kalau kita nak we want to visualize, then it will help. Dia tak bolehlah campur karakter dengan numeric punya data. So kita kena ID our data lah, kita kena kemaskan. Macam mana nak kemaskan data tu? Kita tengok nota yang last week, and further example boleh tengok dekat dalam buku yang saya guna untuk hari ni lah. Depan-depan tu semua how to manage your data. And the first part yang previously yang dalam R tu, kita macam mana how to read and save our data. Kalau kita read data, make sure that our data inside our space, maksudnya directory, yang active directory tu, yang tengah kita guna. And write punya tu, we have write punya syntax tu ialah to save the data dalam XLSX ke atau dalam R code punya format ke, CSV ke, boleh. Ada benda tu. Okay. Rasanya itu je, dah pukul 3 dah habis. Okay ke? Is there any question? Boleh.
InsyaAllah okay.
Okay, tapi nanti if you have question for the lab, contoh untuk analysis of variance, untuk cleaning data ke apa ke, kita boleh bincang. You can ask me. Macam biasalah kita buat assignment kan, kita boleh tanya pensyarah tu kan, betul tak apa yang kita faham ni, kan? We doing in the group and we can discuss before we submit. Okay.
Okay, Doctor. Sure.
Okay.
Alright.
That's all for today class, and I'll put the recorded version inside the ULAN later.
Okay, Doktor. Thank you.
Wassalamualaikum.
Salam.
Thank you, Doktor. Assalamualaikum.
Waalaikumsalam.